Okay, so far we've covered inconsistency in SD, and we've also covered, not in any of the videos in this past week, but we've also talked about what a theorem is in SD, right? So when you are able to derive a sentence without any primary assumptions, that ends up being a theorem. And there's one last one that we want to do, which has to do with equivalence. And remember, we had this notion already on this in the semantic side of our logical system. So we said that two sentences were equivalent if and only if, on every truth value assignment in their truth tables, they agreed on the truth values. But we don't have this semantic notion here. We only have this sort of syntactic notion in SD. So the way we're going to do equivalence in SD is to actually use two derivations. So equivalence in SD, we have to do two derivations. Okay, and here's just what I mean. So suppose we want to show that P is actually equivalent, and this is, I'm using this as a meta language operator here, not the operator in our object language SD, right? I'm saying if P is equivalent to Q, then what I need to do is I need to have one derivation where I assume P as my primary assumption, and I eventually derive Q. And then I need to make another derivation, right, separate from this one. And I need to derive from Q, when this is my primary assumption, I need to derive P. So if I'm able to do this, if I can on the one hand make a primary assumption that P is the case and get Q, and then in a separate, totally separate derivation, right, not a subderivation, a totally separate derivation, if I can make my primary assumption Q and then get P, then I can say that P and Q are equivalent. So let's go over an example. And this is one that's actually from the text. This is 9J. Okay, so I want to claim that A, if and only if B, I want to say that this sentence here is equivalent to, so we'll say is equivalent, I'm not going to write that whole thing out, but I'll say is equivalent to if A then B, and if B then A. So my claim is that these two sentences, this sentence here and this sentence here, that these are equivalent. And again, you know, make sure not to get confused by the fact that this is now an operator in our language, and this claim here is equivalence. This equivalence claim is in our meta language, right? So is equivalent to is something that we're saying about these two sentences that are in our object language. So keep this separate. Is equivalent in our meta language. Keep that separate from the meaning of the symbol in our system. So to check this claim, what I need to do is do two subderivations. So in the first subderivation, what I'm going to do is I'm going to assume A if and only if B, and my goal is going to be if A then B, and make sure we close that off, if B then A. So this is what I have to do in one derivation. Then I need to also set up a different derivation where my primary assumption in this derivation starts with this sentence, the second sentence. So we do if A then B, and if B then A. And again, I'm hopeful this is not too confusing. Sometimes I use the ampersand, sometimes I use the wedge. These are just two different ways of doing the notation, so don't get confused by that. And I don't care which one you use, whichever one you feel more comfortable with. Okay, and in this derivation, my goal is going to be A, if and only if B. So these are the two derivations I have to do, and once I've done these, then I can claim that these two sentences are equivalent with one another. So let's maybe work on this one first. So my goal here, the main connective of the goal, is a conjunction. And if my main connective is a conjunction, I need to at some point derive if B then A, and another point derive if A then B, and then actually be able to conjoin them. So I can think, okay, at some point I need to get this sentence, and at some point I need to get this sentence. So let me write if A then B here, and I'm also going to want to get this sentence as well, but I'm going to put this one up here just for now. So these are my two sub-goals now. And once I get these, then I can do conjunction, introduction, and then I will cite these two lines. So there's going to be two things I need to cite. So now let's start thinking about these two sentences. Well, in order to get, or notice that again, the main connective of this goal is a conditional. And in order to get a conditional, we build it, right? So I'm going to assume A, and the last line of this derivation is going to be B, and if I can get B in this subderivation, then I can use conditional introduction to derive if A then B. And similarly here, so my subderivation is going to have as its auxiliary assumption the antecedent of this biconditional, so it's going to be B. And in my last line of the derivation, I'm going to get A. And then this step is going to be by conditional introduction, and I have to still fill in the line numbers. So now, basically what I've done is just worked backwards from my actual goal, right? I mean, this is what the book calls goal analysis. You just look at the sentence that you want to derive, and you work backwards from that until you sort of unwound all of the things that you can unwind, and once you've done that, you've actually done most of the hard work. Then it's just a matter of trying to look at what you have in your primary assumptions to be able to fill in these subderivations. And this should hopefully be fairly clear now how you would get A in this subderivation, right? We have B as our auxiliary assumption, and our primary assumption says A if and only if B. So I can use biconditional elimination on lines 1 and 2, I wrote them out of order here, but that doesn't matter so much, to get A. And then I've actually completed the subderivation already, because that's all I needed to get. And so now I can fill in this conditional introduction by citing the subderivation that goes from 2 through 3. Okay, so now what I need to do is get the second subderivation. And in here, my sub-goal is to get B. But notice, again, I can use the same strategy that I did up here, right? I have this as my primary assumption, this biconditional, A if and only if B. And I have under this auxiliary assumption, I have A, which means I can actually just use biconditional elimination to get to be able to write B. And there I'm going to cite lines 5 and 1. And now I'm done. I just have to go back and fill in the justifications for the rest. But all the conceptual hard work in setting up the derivation is completed now. So we have conditional introduction here from lines 5 through 6. And then this last line is conjunction introduction, citing line 4 and line 7. Line 4 and line 7. Okay, so what I've shown in this derivation is by assuming this sentence, A if and only if B, I can derive this conjunction. So this is half of the work I have to do to show that these two are equivalent, right? I was able to get this sentence from this sentence. And now we're going to do the reverse. So we're going to assume this sentence here and then try to derive if A if and only if B. So now we're going to do a separate derivation. And our goal in this case is this biconditional. And remember, a biconditional to introduce a biconditional requires us to do two subderivations. One in which we assume A and we derive B, and another in which we assume B to derive A. Biconditional introduction says if you're able to do that, then you can introduce the biconditional. So what we need to do now is work within these subderivations. And unlike over here, we don't actually have another main connective to sort of help guide what we need to do. So here we just have the sentence A. So there's no conditional or anything like here to have to do any kind of subderivations. So chances are we're not going to have to make use of that. So now we look up here and we try to see where A is. Right? So we're going to look at our primary assumption and see if we can make any use of that. And sure enough, we notice that A is the consequent of this conditional that is the conjunct of this big conjunction. So we want to be able to pull this guy out. And so we can do that by doing conjunction elimination. So let me write the line numbers right here. Okay, so we do conditional elimination, and I just have to cite line 1. And for what it's worth, some people have been trying to, whenever you primary assumption that is a conjunction, people have been breaking it apart first out in the main scope line before doing any of the subderivations. And that's a perfectly okay way of going about doing things. I'm just doing it here because I'm sort of working backwards from the goal and then making use of the primary assumptions afterwards. So both of them are perfectly good ways of doing it. The big thing is you just have to be following the rules in the correct way. Okay, so now, since we have the conditional if B then A, and we have B, then conditional elimination allows us to be able to pull out the antecedent here. So we have to cite lines 2 and 3. And then we have the subderivation complete. So now let's do some work on the second subderivation, where B is our subgoal and A is our auxiliary assumption. Well, in the same way as the strategy we used over here, we can actually use that down over here again, because the left conjunct is a conditional where B is the consequent. So let's actually break that apart, the conjunction. We have if A then B, that's the left conjunct here. So this will be by conjunction elimination. That looks like an 8. There we go. From line 1. And then, since we have this conditional, and we have the antecedent of that conditional elimination allows us to pull out B. So we do conditional elimination, citing line 1 and line 6. And then we're done this subderivation as well. And that's all we had to do. So we just finish up our derivation here by citing lines 2 through 4, right? So we need to cite, for the biconditional induction, we need to cite this first subderivation, and then we also need to cite this second subderivation. I'm just running out of room here a little bit, but there we go. We cite the second subderivation where we went from assuming A to B, so this is lines 5 through 7. And that's for biconditional introduction. And now we've completed this derivation. So let's recap what we've shown. We have this claim here that says, look, this sentence is equivalent to this sentence. What that means is you can assume this sentence and derive, using the rules of SD, this sentence over here on the right. And vice versa. You can assume this sentence as a primary assumption in SD, and then derive, using our rules, A if and only if B. And that's exactly what we've done here. In the first derivation, we've assumed A if and only if B to derive this conjunction. And then in the second case, to show the other direction, we've assumed this is our primary assumption and then derived A if and only if B. So when you do this, you can then claim that those are equivalent.